Okay, section 2 of chapter 5, we're going to learn special factoring cases. Okay, and to begin to illustrate, I'm going to share with you one of my pet peeves. You know what a pet peeve is?
Oh, something that bothers you?
Yes. Yes. Okay, so this is my pet peeve when students do this.
No. Because they didn't do the exercise.
This is never true. Okay? And so many students do it. ACT will have a question like this, and one of the answers will be x squared plus 4. Do not choose that one. Okay? There is always a middle term when you FOIL this.
Do you hear that, Catherine?
Always. Because x plus 2 squared is x plus 2 times x plus 2.
Right.
If I FOIL this, I get x squared plus 2x plus 2x plus 4. There's always a middle term. Okay? Now, what I'm going to show you is a trick to figure out how to find that middle term without having to FOIL. You want to know that?
I do. Please.
So if you ever have a problem, let's just do this one. Actually, let's make it 2x plus 3 squared. Okay, square the first term. Square the last term. Because we know there's a middle term, the way you find the middle term is you multiply those two together times 2. Multiply the two together times 2. So what's 3 times 2x? 6x times 2, 12x. That's how you would expand it without having to FOIL. Okay? Look at the rule. This times this is 2x times 2 is 4x. Okay? So the first term is always the first term squared. The last term is always the second term squared. The middle term is always this times 2. Okay? If you can't remember, then just FOIL. But as you get into more complicated problems, not having to FOIL this just saves you time. Does that make sense? Okay? So what we're going to talk about today, though, is when we see special cases of factoring. Okay, when you see perfect squares at the end, do you recognize that x squared is a perfect square?
Yes, it is.
Okay, 9 is a perfect square. Okay, so what you're going to do is try just taking the square root of both and doing this. Then you can check the middle term. Does it make sense? This times 2 is 6. So if you have perfect squares at the end, take the square root of each one of them, put it in parentheses and square it, check your middle term, make sure it makes sense, and now you factored it without having to do any special looking for factors of 9 that add up to 6. Now that still works.
I'm confused about the rule. Where did you get 2?
Squared?
Okay, you said this times 2.
Because that's the rule I just went over here to find the middle term. You take this times this, which is 6x, times 2 is this.
Oh, just times.
Okay, this is the, if I do it here, I could FOIL it and get x squared plus 2x plus 2x plus 4 and combine. Or if you just know, it's this times 2 is your middle term. Okay, so I'm just checking my factoring to check my middle term. So what I was going to say was the rules we learned yesterday still work on these kinds of problems.
We don't have to do it.
But if you have a shorter way to do it by just taking the square root of both, it's a special case. Okay, same is true. Let's do I'm thinking here. I'll just do one. 4x squared. So again, square root of this, actually this isn't right. Let's do this too. Square root of this is 2x. Square root of this is 2. Middle term is 8x. So if I were given this and I saw the perfect squares on both sides, just take the square root of both, square that, check your middle term. It's probably going to be right. If not, then it's not factorable.
Would you take the 4 over to the 4 and then square root it?
Mm-mm.
Okay.
Okay, let me do another one. Everybody agree with that?
Yeah.
Okay, so what I'm trying to show you is a way to recognize this and factor it without having to do the special way we learned yesterday.
Right.
Okay, and it only works when the bookends, the leading term and the constant, are perfect squares. Okay, so you're going to take the square root of this, and the square root of this. This sign goes in the middle.
I divide 2 to 18.
You can,
36.
oh, what did I do?
The 9
This is 3. Square root of 9.
6 times 2 is 12.
Okay, it works the same if this is negative. This just becomes negative, and this becomes negative. So whether it's positive or negative, it doesn't matter. Okay, so this is called a squared binomial, because binomial means 2 terms. This is a trinomial. It has 3 terms. A binomial is 2 terms squared. It's a squared binomial. Okay, and it's a perfect square trinomial that factors to a squared binomial. Okay, the second special formula, if you have 2 perfect squares with a negative sign between them,
What are you going to do?
you're going to take the square root of the first term and the square root of the second, and you're going to multiply them with 2 negatives, or positive and a negative. Okay, let's try, and FOIL this. X squared minus 3x plus 3x. What happens to the middle terms? It only works with perfect squares.
That's the same thing.
I know. That's what I'm showing you.
Oh,
This factors to this, and I just checked it by foiling.
it's been a day.
Okay, so what is... How do I factor that?
So 4x, or 2x, sorry, plus 8, no, 4, parentheses, 2x minus.
There you go. Special cases. That's what this section's about. Recognizing perfect square trinomials and how to factor those back into squared binomials, and then how to factor something called a difference of squares. Because this is a difference of squares. And a difference of squares factors into 2 parentheses, same terms, one's positive, one's negative. And that's what forces the middle term to drop out. Questions? Okay, that's it for today.
I need help on, by the way.